Hi students, in previous video we discussed the definition of chemical bond and its types. In this video we discuss the detailed information about the formation of ionic bond or electrovalent bond. The ionic bond was proposed by a scientist, Cosell. Now we discuss the definition of ionic bond. The electrostatic force of attraction between the oppositely charged ions formed by the transfer of electrons is called ionic bond. Conditions for the formation of a ionic bond. Ionic bond is formed between two dissimilar atoms. That means here we can assume that A is one atom, B is another atom. That means the ionic bond is formed between two different type of atoms. Here one of the atom must be a metal with higher electropositivity. For example, we can say A as a metal atom. Already we discussed in periodic table chapter, the metals are having higher electropositive in nature. So the condition 1 is a metal which will be having higher electropositive character. Another atom must be a non-metal with higher electronegativity. That means here we can assume that B is a non-metal which is having higher electronegative character. The second condition is the electronegativity difference between the two atoms, that means A and B, is always greater than 1.9. That means during the formation of ionic bond, the electronegativity difference between the two atoms must be greater than 1.9. The examples for ionic bond are sodium chloride, magnesium chloride, magnesium oxide, sodium oxide, aluminum trichloride. Now we discuss the formation of a sodium chloride molecule. The formation of sodium chloride molecule takes place by following 3 steps. Step 1. Formation of a cation. Atomic number of sodium is 11. The electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. In short form, we can write down as 2, 8, 1 configuration. The sodium atom, in order to get octet, that means 8 electronic configuration in their valency shell, they lose 1 electron, that is the electron which will be presented in third orbit in s orbital. So, and get nearest noble gas, that means neon configuration, 2,8 configuration. So we can write down as sodium having the electronic configuration 281. In order to get neon configuration, it will be loses 1 electron and that will be converted as Na+. If any atom loses the electron, then it will be gets a positive charge on the top of that element. So we can write down here as Na plus electron. Now Na plus, that means the positively charged atoms are called cation. This is called a sodium cation. This sodium cation having 8 electrons in their valency shell. That means it will be following an octet rule. In this configuration, the Na plus ion is very stable. Step 2 involves the formation of anion. For example, the atomic number of chlorine is 17. Electronic configuration of chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. In short form, we can written as 2, 8. That means second orbit contains 8 electrons and third orbit contains 7 electrons. So 2, 8, 7 electronic configuration. Here in chlorine, the outermost orbit, that means third orbit, contains 7 electrons. According to octet rule, this chlorine atom will get more stable by gaining 1 electron by any other element, here from sodium element. So we can write down here as the chlorine will gain one electron which will be loosed by the sodium atom, and that will be converted as a Cl minus ion. That means the negatively charged species or atoms are called anion. This name is chloride anion. This chloride anion having the electronic configuration 288 after gaining one electron from sodium atom. Here in this state, the chloride anion is very stable because it is having now 8 electrons in their valency shell. Step 3. Formation of ionic bond. That means sodium chloride molecule. The electrostatic force of attraction between sodium cation and chloride anion form a new bond. That bond is called ionic bond. What is meant by a electrostatic force? The force that will be generated between the oppositely charged ions. That force we have to name it as a electrostatic force. Now the electrostatic force that will be generated between the sodium cation and chloride anion. This force, that means this electrostatic force, leads to the formation of a new bond. That bond is called ionic bond. In this way, the sodium chloride molecule is formed between the sodium cation and chloride anion. Now we discuss the formation of magnesium chloride molecule. Step 1. Formation of magnesium cation. The atomic number of magnesium is 12. The electronic configuration of the magnesium is 1s2, 2s2, 2p6 and 3s2. In short notation, we can write down as 282. But according to octet rule, this magnesium atom will get stability by losing their outermost or valency 2 electrons. So we can write down here as magnesium that will be loses 2 electrons. That means Mg gives rise to Mg plus 2 electron. In this reaction, we can get the magnesium cation, which will be having 2,8 configuration in their outermost orbit having 8 electrons. Step 2. Formation of chloride anion. The atomic number of chlorine is 17 and its electronic configuration in short notation can be written as 287. In order to get 8 electronic configuration, the chlorine will get 1 electron which will be loosed by the magnesium. Here the magnesium loses 2 electrons. So we can write down here 2 chlorine atoms that will be takes 2 electrons and that will be converted as a C2Cl minus. That means here the chlorine will takes 2 electrons and that will be converted as a 2 moles of chloride anions. Here the chloride anion in their outermost orbit having 8 electrons. Now in step 3, formation of magnesium chloride molecule. The electrostatic force of attraction between the magnesium cation and 2 chloride anions form magnesium chloride molecule. In this way, the magnesium chloride molecule formed between the force of attraction between magnesium and chloride anion. Thank you for watching this video.